This question asks, consider the reactions below and choose the true statements. So this is a difficult quiz question because it's got multiple statements that you have to decide, are they true or are they false? And it also has multiple reactions that you have to consider. So the way that I would approach this question is to kind of first think about the reactions and then think about the statements and whether they're true or false. So I'm going to take you guys through my thought process. Reaction number one has a primary alpha carbon, but a sterically hindered beta carbon. So I'm going to write that in. Beta carbon is hindered, and that can have an impact. Next, I'm going to take a look at my reagent. This reagent has a positively charged sodium that acts as a counter ion, and then it's got a negatively charged thiol. So this is a strong nucleophile only. Okay, phthalates and things like cyanides and halides only act as nucleophiles. Lastly, I'm going to take a look at my solvent. This is acetonitrile, and this is a polar aprotic solvent. So thinking about all of these factors, a primary but hindered substrate, a strong nucleophile only, and a polar aprotic solvent, I'm thinking that this reaction is an SN2 reaction. The reason why is because our substrate is fairly sterically unhindered. We have a strong reagent and an aprotic solvent. So all three of those factors favor SN2. So I'm going to think about what my product would look like. And we're going to replace the Br with an SH. Okay, the second reaction, we can kind of use the same thought process. This is a primary unhindered substrate. Okay, because the beta carbon only has one R group attached to it. We have the exact same reagent, sodium thiolate, so it's also strong nucleophile only. The difference here is the solvent. So in this case, our solvent is polar protic. Polar protic solvents are not ideal for bimolecular substitution reactions or bimolecular elimination reactions, but it doesn't prohibit the reaction from occurring. It just doesn't necessarily speed it up. So the reaction can still happen in something like methanol or water. It's just not an ideal solvent. So this reaction is also going to be SN2. Again, a primary substrate, a strong nucleophile only. Both of those two factors strongly suggest that we are going to see SN2 occurring. So this would be our product there. Solvent is a very minor factor. So it's much more important that you have a appropriate nucleophile and an appropriate substrate in order for SN2 to occur. The third reaction has the same substrate, primary, unhindered, and the same reagent. So again, a strong nucleophile only, but our solvent is different this time. This time our solvent is DMSO, and DMSO is a polar aprotic solvent. So as we discussed in the first example, aprotic solvents favor our SN2 reaction as well. So all three of these reactions are SN2. They all make thiols as products. So now that we've thought about the reactions, let's go over and take a look at our statements. Statement number one says reaction 3 is the fastest reaction. So in order to kind of think about which reaction is fastest, you have to think about what favors a SN2 reaction. SN2 reactions are favored by limited steric hindrance. They are favored by strong nucleophiles, and they are favored by polar aprotic solvents. So the reaction that has all of these things going for it is reaction 3. Reaction 3 is primary unhindered, has a strong nucleophile, it has a polar aprotic solvent. So this first statement is true. Reaction 3 is going to be faster than reaction 1 because of the beta carbon. The beta carbon of reaction 3 is unhindered, whereas the beta carbon of reaction 1 is sterically hindered. Reaction 3 is going to be faster than reaction 2 because reaction 3 is occurring in an aprotic solvent, while reaction 2 is occurring in a protic solvent. So that's why statement number 1 is indeed true. Let's take a look at statement number 2. Statement number 2 says reactions 1 and 3 both occur in a polar protic solvent. This one is false. We do not have protic solvents in reactions 1 and 3. We have aprotic solvents. So statement number 2 is false. Statement 3, reaction 2 will not produce a product as drawn. So this is a little bit tricky, but the answer is false. This one is false because, as we discussed when we were walking through the reactions, just because the solvent is polar-protic doesn't mean the reaction won't occur. It just means it's not going to be as fast as it would be in an aprotic solvent. So solvent does not limit which reaction happens. All right, so statement 1 is true, statement 2 is false, and statement 3 is false. So this question, again, was asking which of the statements is true. So definitely double check. What are we looking for? Only statement 1 is true. And so our answer is A, 1 only.